Okay, welcome to this next tutor training video about factoring. We are on method number 5, which is when there are special cases. You'll notice that there are some special cases that are trinomials, right, 3 terms, and the rest deal with when there are only 2 terms. Okay, at the end of the video, we're going to do one that involves some of the other methods, so make sure you don't forget about those. Alright, let's first look at perfect square trinomials. This is an example of one of those, but let's just try AC method on this, because of course that will work for any trinomial. So we're going to multiply 9 times 49 and see what we get. It's a pretty big number, 441. So just like the AC method says, you're going to see what factors will add up to be 42 and multiply 200 to be 441. Turns out that is 2 of the same number, 21 plus 21x. Okay, and we're going to split this, and we're going to factor out of the first 2 a 3 and an x. Left with 3x plus 7. And from the next 2, we're going to also factor out a 7. And we're left with the exact same thing in the parentheses like we planned it. So we factor that out, but what also happens on this problem is that the leftovers end up being the same in the other parentheses. So we could really write that as 3x plus 7 times itself. These perfect square trinomials always factor to be a binomial being squared, right? The same thing twice. And here's how you can recognize if it is a perfect square trinomial or not. Look at the first term and the last term. If we take the square root of those terms, right, square root of 9 is 3, square root of x squared is x, and the square root of 49 is 7. So we get nice whole numbers for our coefficients when we take the square root of the first and last term. That's not true of the middle term, but what happens if we multiply those square roots, 3x times 7, we get that middle term, 21. If we then multiply that by 2, we get 42, which is the middle term. Ta-da! So here's the perfect squares. Here's how you can know that they are perfect squares. The first term and the last term are perfect squares, meaning that when you take the square root, you get a whole number. And the middle term is twice the square root of the first and the square root of the last. 3 times 7 times 2 in this case. And if that is true, then you can factor it just by taking square roots. Looking at this explanation here, ax squared plus, this can also happen with a minus bx, but it always has to be plus c. Okay, whatever b is will give you the sign for your parentheses. So you can take the square root of the first term and square root of the last term and plop those in parentheses. Let's look at this example. Okay, first, let's check to see if it's a perfect square trinomial. Square root of 16x squared is 4x, nice whole number on the coefficient. Square root of 25y squared is 5y, again a perfect square. And now we're going to check or multiply 4 times 5 times 2. That does give us 40 here in the middle. So we can go ahead and just write out our answer. Square root of 16x squared is 4x. Square root of 25y squared is 5y. Because there's a minus there with a b, we're going to have a minus here. And square that whole thing. That's our answer. Ta-da! That is perfect square trinomials. Of course, like we saw at the beginning, you can use the AC method. Not a lot of students prefer perfect square trinomials. They might just use the AC method, and that is totally fine. But you can help them do it either way now. Let's look at the binomials. Okay, we're going to start first with just if there's an x squared. We'll look at it cubed in a minute. So we have 36x squared minus 25. Notice there is no middle term, there's no bx. And so how do we do the AC method? Well, you could use the AC method pretending like there's a 0x there. 0 times x is just 0, so we can always add that in. So let's say we do the AC method on this now trinomial. 36 times 25. Another nice big number for us. Oh, and we gotta remember it's a negative 25, right? C is negative in this case. And that gives us 600. Negative 600. Which if you split that up, you could have positive 30 and negative, oh, not 6, what, I was reading wrong. Negative 900, there we go. Positive 30 and negative 30, which we can put in the middle to add to be 0. I'm reading my notes wrong on that one. Minus 25, okay, chop it. I can take out of the first two a 6x. I'm left with 6x plus 5. And I can take out a negative 5. So if I factor out that 6x plus 5, I'm left with, in my other parentheses, 6x minus 5. So when I multiply these together, I'll get 30x and minus 30x in the middle, which cancels out. So the trick on this one is we need the same exact terms, but with a plus and a minus in each parentheses. And notice if we take square roots of the first and square roots, just ignoring the minus, of the last term, we get 6x and 5, which tells us what to put in the parentheses. There you go. Here's our difference of squares. Ax squared minus c, where a is a perfect square and c is also a perfect square. You can just take the square root of the first term, and the square root of the last, and the square root of the last, and put a plus and a minus. Let's do an example. So square root of 4t squared is 2t. I have two parentheses. And square root of 121 is 11. And I'll have a plus and a minus. Ta-da! All done. That's our difference of squares. What if, though, there are cubes? So here is a formula to remember. We have both if there's a sum and if there is a minus for the difference of cubes. And so we're going to follow this pattern. Whatever is being cubed, so you can just cube root the first term, is going to go in the first parentheses. Same thing is true for if there's a minus. Okay? And then the cube root of the second term is going to go in the first parenthesis as well. And then we're going to square it. Square both of them, they both get squared, and then multiply them together here in the middle. Let's do an example. Whoops, went too far, sorry. Okay, so 8x cubed. If I cube root 8x cubed, I get cube root of 8, and the cube root of x cubed is 2x. Cube root of 27, or you could even put the negative in there, is 3. So that's my A and my B. So for a minus, that's going to equal out to, I have a binomial and a trinomial, A and B. First thing squared here, and last thing squared here. And in the middle, I'm going to multiply them together. Okay. There's lots of different ways to remember this. There's a song. It's on the wall of the math lab. One way I remember the signs is, this is true for both plus and minus. The first sign is the same. Get a different color. Same. The second sign is the opposite of the original, so it was a plus sign, now it's a minus. It was a minus, now it's a plus. So same, opposite, and this one is always positive. Soap. So same as 8x cubed minus 27, so same. 2x squared opposite, and then always positive. And then to simplify, I'll just multiply those squareds in the last one. So I get 4x squared plus 6x plus 9. Okay, one thing to remember, this trinomial is actually always a prime. prime meaning it cannot be factored more. So if we did the AC method, 4 times 9 is 36. None of those factors are going to add up to be just 6 in the middle, and so we can't factor it anymore. Speaking of prime, let me go back one. If we tried to do a similar process with a sum of squares that we did with the difference of squares, so say it was x squared plus 9, there is no way for me to factor, right? If I do a minus and a plus, that would give me negative 9. If I do plus and plus, that would give me a middle term. If I do minus and minus, that would give me a middle term. So with whole number factors, there's no way for me to factor a sum of squares. So what I always remember is for a sum of squares, so a binomial that's not cubed, no cubes, if there's a plus sign, plus means prime. But for cubes, we saw in this one, that we can do it if there's a plus sign, right? Just like we can't take the square root of negative 4, but we can take the cube root of negative 8. That's okay. It's a similar idea that we can do plus and minus for cubes, but not for squares. All right, here is a summary of all the things, and we're going to do one more problem just to practice a lot of these methods. Okay, first step, number 1 rule, really important, is to factor out any common factors. That makes every problem easier if you can do that. Then it depends on how many terms you have. If you have 4 terms, you're going to chop it, factor by grouping. We learned that already. And then if there are 3 terms, you have a lot of options. If it's a fast trinomial, just look for factors that add up to BB. If it is a slow trinomial, then you can use that AC method or do some guessing and checking. Perfect square trinomial, if there's perfect squares, then you can follow that pattern we talked about in this video. So lots of trinomial options. If your student is overwhelmed by how many methods there are, just keep in mind that the AC method will work for any trinomial. Fast, slow, perfect squares. If they can only remember one trinomial method, make it that one. Okay, 2 terms, we got some options. If it's perfect squares, it only works for minus signs, right? And if it's perfect cubes, it works for plus or minus, that pattern that we learned. Another important thing, it's already got a gold star around it, is to check to see if any of your answers can be factored more. That's what we're going to talk about right now. So let's look at this problem. Make sure to factor until you are done. Okay, 4 terms, let's start chopping now. We need to follow the number 1 rule, which is to always factor out any common terms or monomials. So looking at all 4 terms, I can factor out a 2. That's going to make my life a lot easier in the long run. So I'm left with x to the 3rd minus 3x squared minus 4x plus 12. Okay, now I have the 4th term. I don't have any other common factors, so I am going to chop it, chink, or group it. I can factor out x squared. I'm going to ignore the 2, but it'll come back later. X minus 3. And over here I can take out negative 4. X minus 3. All right, here's my 2 back. And I have x minus 3. And for my leftovers, x squared minus 4. No, I'm not done. Hooray! Nope, not done. All right, I can't factor the 2 anymore. That's done. It's just a monomial out front. X minus 3. It's a difference, but it's not perfect squares, so I can't keep going. But in the 3rd parentheses, or 2nd parentheses, I can use the difference of squares. That's a binomial. So I'm going to keep going. I'm going to leave this out here. Square root of x squared is x. Square root of 4 is 2. 1 plus, 1 minus. Let's double check. This is done. This is done. Okay, that's got a plus sign. Plus means prime. X minus 2, no perfect squares there, so it is done. Especially when you're tutoring, make sure that they are completely done with each problem that can't be factored anymore, and help them to recognize when they're done and can check each part of their answer and make sure that it can't be factored anymore. Alright, that's all the factoring. Covered all 3 of these topics. Go ahead and try that assignment.